arguments. Second, keyword arguments or named arguments. Third, default. Default is slightly different. Then variable length or variable number of positional arguments. Positional. And fifth one is variable length, variable number or length, keyword arguments. So these are the different ways of passing arguments, and this four we have already seen. Fifth one is variable length of keyword arguments. In this case, like variable number of positional arguments, the actual parameter, the formal parameter is actually asterisk followed by some name, which generally we give args. And variable number of variable length keyword arguments, it is double asterisk KW args. This is the traditional name or conventional name we give, and it is represented with double asterisks, and it is actually a dictionary. So the variable and keyword arguments is held by dictionary in the function definition, and this is held by tuple. So this is represented with asterisks and this is represented with double asterisks. Why dictionary is because when I say keyword, it is name equals to value pair. So name equals to value. This is considered as key and this is considered as value because it's a pair. So it is available in the form of dictionary there. It is available in the form of dictionary. So if you take one example here. So variable number of keyword arguments. So I'll define a function, define some sample. So I'll say double asterisk. First, I'll take separately the keyword arguments, variable number of keyword arguments. Later, I'll mix it. So I'm writing this, and here, because it's dictionary, so you can find the length of the dictionary, length, KW args. And then for each key in, or I'll take each name in KW args, will print name, comma value. So this is the keyword arguments. So I'll prepare it for execution. Sorry, I think I have not shared. I think I have to share it. You have to share. Okay. So now I'll call something like sample, something like what I'll do is I'll say name equals to, I'll just pass key value pairs. Then I'll say matches equals to 100. Then runs equals to 9,000. So this is I'm passing name value pair. Now I'll execute this. Sorry, name here I cannot name value I have to get from this one. So KW args. Args because value is not available, so I'll get it from the using name. So I have to write this way, so that's why it is giving error. Now I'll execute this. So now it is giving, see, name. This will be this name value pair is prepared as dictionary, and dictionary is available here as a reference. Now using that reference, I'm able to access name value pair. So I can pass any number of key value pairs. Then here it will be keep on giving this. So I have to print here. I think I'll print it. I'll say print. That's why length is not coming. I'll I'll execute this. So I'll execute this. So it is giving 3. Suppose I may add some more here. Average equals to 61.7. So now if I execute this, it will be included. So that key value pair is available as dictionary, and that dictionary can be accessible as key value pair. So this is how we can use key value pair. Now I can combine all. Even we can have positional arguments, then default arguments, then variable length keyword variable length positional arguments. So we can have a combination of all these things. Here I have taken separately. Now what I'll do is I'll take one more function. I'll mix with some other, like I'll take something like define mix. I'll say position and keywords, position and keywords. So I'll take asterisk args, then double asterisk KW args. So here, so I'll say print number of variable length arguments. So I'll say len args. Then I'll take number of variable length positional arguments. Then this is keyword arguments. So here I'll say KW args. Now I'll call this. I'll call with the name mix. So mix POS KWS. Now I can add something like before this, I may take some variable a equals to 20, a equals to 25. I can take b equals to 100. Then while I call, I can say a comma b comma 50. Now in this case, this 3 will go. Let's see, from here name value pair is coming. So this part will go into KWRs, and before that, whatever I give, that will go into args. Now if I execute this, I'll execute this first. So number of positional arguments A, B, 50 will go into args, and remaining this key value pair, name value pair will go into key value pair will go in key value pair into will go into KW args. So we are having both positional arguments and keyword arguments. Based on what you pass, here I'm passing just a series of values. Of course, some values with some associated with some variable, some we are passing directly. So whatever it is, if it is simple value, it will go into args, and if it is key value, it will go into KW args. Now I can skip when I call this, I can skip one of them. It is not necessary that all I need to pass. So if I skip this part, then that will be 0. That's all. So here, if I skip this, it will take args, because both are variable number. So it is not necessary that we have to pass. So keyword arguments will be 0. I can skip the first part and pass the second part. So it is as per our requirement. So there will be surely flexibility when we have variable number of positional or keyword arguments. Either we can pass 0 arguments or any number of arguments, it will accept. But once if you have positional arguments, it will be binding on caller, whichever function that is calling. It requires to pass the values for all the positional arguments, because it is fixed. So here variable length positional arguments are 0, but variable length keyword arguments are 4. I can mix all. I can mix. Suppose if I take this definition again, I'll mix some more here. Here I have given only variable length. I'll mix with fixed positional arguments, then fixed keyword arguments. I'll use this here. So I'll name it as mix more. Mix more. Here I may add something like fixed one, positional fixed one, positional fixed two. These are compulsory, and I'm using the variable length arguments and keyword arguments. So I'll say print fixed arguments, fixed positional arguments, fixed positional arguments. Here, fixed positional arguments, I can add, mention them like PF1, comma PF2. If now once I mention this, it is compulsory for us to pass. So if I have this, if I call this, suppose if I say mix more. Now it is because these are fixed arguments, it is compulsory to pass them. If I don't pass, suppose if I pass one, then it will be error. It will not accept. It says PF2 is required. You can observe it says PF2 is required. So required positional arguments. Now if I pass 10 and 20, now I'll take this and execute it again. Now, if I pass one more here, now whatever the required thing, compulsory things, I'm passing. So remaining things I'm not passing, it's okay. Now it will be executed. So it says the fixed positional arguments are 10 and 20, and I'm not passing any variable number of arguments. So it is 0, 0. Now I'll take mix more. Then I'll take 10, comma 20, comma 30, comma 40. So as long as I give values, it will go into variable number of positional arguments. As long as I don't give the key value pair, the keyword arguments will be empty. Variable number of keyword arguments will be empty. So first two will go into fixed one. After that, remaining whatever is there, as I told you in the last session, remaining will go into variable and positional arguments, and keyword, because there is no key value pair I am giving, so it will be empty. The keyword arguments will be empty. Now if I take again, so I'll take 100, comma 200, then I'll say name equals to Python. Then suppose type L type, language type equals to suppose or TP, because type is a keyword. So I'm saying TP equals to language. So I'm passing some keyword arguments. I'm skipping the variable length positional arguments. So it's okay. So I can skip in any order if it is variable length, but if it is fixed, I must go for it. Now I can also have fixed keyword arguments. So this is one important point. When I take fixed keyword arguments, see here, I'll take explanation, then I'll go for it. See, default you forget because it is part of positional. So I'm not going to give default. Now, if I take the function name here, so function. So function name, if you take here first fixed positional, then this may contain, within this I may contain default arguments. default arguments. Now after that, the args, this is actually variable length, positional arguments, and I can also have keyword arguments. This is fixed keyword arguments. This is one more option. So fixed keyword arguments. Now, if I keep something after asterisk, after variable length positional arguments, it becomes a fixed keyword arguments. Then variable length keyword arguments. Now the order must be strictly this way. So I must first have, if I want to have all, I must first have fixed positional arguments, then variable length positional arguments, then fixed keyword arguments. Means it's not variable length. If it is variable length, I have to go for this. If it is variable length, I must go for asterisk. Now, whatever I keep after variable length arguments, this will be positional arguments, fixed keyword arguments. Sorry, it will be fixed keyword arguments, and I must keep fixed keyword arguments if at all I want. I must keep it in between these two. I must keep it in between these two. If I want to have all, I must follow strictly the same order. First fixed positional arguments, then variable length positional arguments, then fixed keyword arguments, then variable length keyword arguments. The default arguments, if at all required, we have to keep it within fixed positional arguments. So this is all arguments, but the order must be strictly followed. So I'll take one more example here. So I'll say define mix all. So I want to have all. So I'll take something like positional fixed 1, positional fixed 2, then variable number of args, then keyword fixed 1, keyword fixed 2, then keyword variable. So this is the order. So I must use them. So I'll say I'll take this statements here, whatever present. So I'll take this statement, I'll copy from here. I'll take this from here. So then I can take the fixed keyword arguments. Fixed keyword arguments I'll mention here. Fixed keyword arguments. This is fixed keyword arguments. Then I'll keep this. Now I'll execute this here. This is must and this is must. I must this I can directly pass value. Here I must refer it with the name. I must refer it with name. So if I execute this, I'll say mix all. Now I'll say 10,50. Then I don't want to give any argument, this variable length positional arguments. So I'll say kf1 equals to 100. It is not necessary to follow the order because it is keyword. Kf2 equals to 100. Then kf1 equals to 200. So these are the compulsory things to pass. Compulsory to pass. So here, sorry, here I have to mention kf1 and kf2. So that is the mistake, kf1 and kf2. I'll execute this. So here, see kf2 2, because I am referring with name, the order is not important. KF2 will go into KF2 and KF1 will go into KF1. So that's what we are getting. KF2, KF1 and KF2. KF1, KF1 I'm giving 200, KF2 I'm giving 100. So it is same we are getting, and we are getting the result. Now I'll try to skip the keyword arguments, fixed keyword arguments. I'll call this again. I'll skip this. See what happens here. So it is giving error. It is saying missing keyword argument KF1. So we cannot skip fixed keyword arguments. But if I want to have fixed keyword arguments, it is in between variable length of positional arguments and variable length of keyword arguments. Even if I give here, now I'm giving 100, 10, 50. Now if I give 100, 200 like this, now this 100, 200 will be taken as variable length positional arguments because I am not mentioning any name. So it is also an error. Say KF1, KF2, where 100, 200 going, they are going into args. So when I take fixed keyword arguments, I must pass them. Somehow I have to pass with name. Name only I have to pass. KF1 equals to 100. KF2 equals to, till I give this, it will not accept. So now it will accept. Now I can give, I'll check this. I can give this as default. When I give this as default, then it will be, now I can skip this one. So I'll execute this. So when I give the default, now I'll execute this. Then it will not take default value because we are passing the value. Now suppose if I skip the second one, it is allowed positional. I can skip the second one because it is default one. Default value I am giving. So now it accepts. Now same thing I'll try to do for keyword arguments. So I'll try to give keyword argument 0. Now I'll try to execute this. Now I'll try to execute this one. Sorry, KF2. So here, even the keyword arguments you can make default. So I can make keyword arguments default. So I can make keyword arguments default, whichever is fixed argument that I can make default. So here, I think I've given only this as default. So the this may also carry some default values. This part may also carry some default values. So Python has got a lot of flexibility in passing parameters. No other language has got so much flexibility. So now here, because PF2 is default and KF1 is default, I can skip them. But if I pass them, the only passed value will be taken. So now KF1 0 is overridden by KF1 200. So KF1 will be 200. Now if I use if I pass everything here, so I'll take this and pass some values. So yeah, I'll take this and call it again. Here I'm taking 100, 200. Now after this, I can also write suppose 25, 35, 25, 35, then kf2 equals to 50, kf1 equals to 75. Then all parameters are passed. Now you see the output. So fixed positional arguments. Sorry, here I'm saying mix more. I have to call mix all. So that is the mistake here I did. So mix all. To call this. Sorry, bracket is missing here. So I'll execute this. Now see, fixed keyword arguments are 50, 75 and 50. Fixed positional arguments are 100, 200. Variable number of variable length positional arguments are 25, 35, which are 2. Then number of variable length keyword arguments are 2. These are the 2 arguments. So this is how I can mix. When I mix, the order is important. First, the positional arguments, fixed length positional argument, then the keyword arguments, then fixed length keyword, first positional arguments as I gave you here, first positional arguments, fixed positional arguments, then variable length positional arguments, then fixed length keyword arguments, then variable length keyword arguments. So the order is must. Excluding that order, remaining thing is flexible. I can have any number, but once I have fixed positional and fixed keyword arguments, I must pass values to them. I must pass values to them if there is no default argument. So fixed positional arguments and fixed keyword arguments may contain default arguments. If they contain default arguments, even I can skip them. So this is the flexibility that is there in functions in Python. So this we have discussed about all arguments. Now, if you have any doubt, you can ask at the end. I'll go to the next one. Now, normally, if you take the return value, I told you the function. When I take a function, I am defining function. It takes input. Inputs, we have seen the different ways of passing input. So it will take input and any return returns the output. Normally, in returning the output, in other languages, there is a restriction. The restriction is it can return only one value. It can return only one value. One value. That is the restriction. If you take Java, C, any function or method can return only one value. But in Python, it can return any number of values. This is not there, no such restriction. Any number of outputs can be passed. Any number of outputs can be returned. Can be returned. So this is how we do it. For example, suppose I have a function. I have function. I'll take function like define add mult. I want to get multiplication and addition of several numbers. I'll take args. So here what I'll do is I'll take something like sum equals to 0. I'll take each one and product is 1. Sum is 0 and product is 1. So I want to sum all of them and also take multiply all of them. So for every number in args, for every number in args, what I'll do is I'll say sum plus equals to num. Similarly, product into equals to num. Now, normally we can return only one, but here it can return two, all, any number. There is no such restriction. So this is a one more flexibility in Python. Other languages there is only restriction. Now I can call, so I'll take int LST, sorry, LST equals to, I'll take 1, 2, 3, 4, 5, 6, 7. Just I'm taking series of numbers. Then I'll say LST sum, comma LST SLST PLST equals to, I'll say add mult. I should not say LST, because if I say LST, it will be passed as one list. I'll take it as asterisk. Now I can print them. Print SLST and PLST. Now we'll see what is happening. So it is giving the result. So sum, it is actually, if I take this 10, 20, 30, and product is product of this, so it is 6480. 1, 2, 3, 4, 5, 6, 9. So it is giving 6480. So if I take 3, 4, 12, 72, yeah, it is correct, 6480. So I can see one point here to note is a function can return some output, but most of the languages, the restriction is the return, whatever function returns, that should be only one value. But here it can return any number of values. Here it is returning 2 values. So the 2 values will be available here. Like this, they are available as the all values can be taken here based on the number of values returned. You have to mention here number of variables. That's all. So this is how a function can return multiple values in Python. Now one more thing is the return value can also be a tuple. So if I take the return value, instead of this, I'll say as a tuple. I'll use brackets. Now it is available as a tuple. So here, if I print the individual types, so if I say type SLST, then type PLST, just I'm giving P here, product of list. So I'll execute again. So they are integers. So we'll get integer, both integers. Now if I return this, now I'll execute this. I'll name it as with a different name. I'll have add mult, and I want it will be available as a tuple. The result is available as tuple. So I'll execute this. Now I can take result. I'll take the same thing, same LST. Now I'll say here res tuple. I'll take this res. Now this is available as tuple. So I'll execute this. Now I'll execute this. Now it is available as tuple. So I can take individual values. Those product and sum are available as so res 0 is product. Sorry, sum. Res 1 is the product. So I'm getting the result. So you can take individual items, or you can take a tuple of items, it is up to us. So suppose here, if I take this. Now, one more point here, what you want to, you have to observe is, yeah, here even see it is not actually based on the brackets what you mentioned. If you mention only one variable here, this will be automatically tuple. So here I'm not using using any bracket. So now if I execute, I'll take this as something like T res. If I execute this, so this is also available sorry, this one I'll take TRES and I'll print TRES 0 TRES 1. So based on what we are giving the destination variable, so the type changes. Suppose if it is returning here, it is actually written as a tuple, and the tuple will be copied into either into tuple or individual variables. Here, to make it clear, what I'll do is I'll take a tuple T1 equals to, suppose if I take 100 comma 200. Now when I say this is a tuple T1, now I can take this T1, I can say A comma B equals to T1. So I'll execute this. I'll execute this. See here, I'm assigning tuple to individual variables, and those because I'm assigning two individual variables, so it will be directly assigned. It will be unpacked and it will be assigned 100 as 100 and 200. It is actually if you take the type of A is integer. Type of A is integer and type of B, of course, is also integer. Now, if I remove one here, and I'll keep only one variable. Now A is not integer, A is tuple. So that's what happening there. So what actually happening here in a function is, now it is a tuple. So what actually happening here is, when the function is returning more than one value, it will be returned as a tuple. It will be returned as a tuple. And if the receiver is a single variable, then that will be tuple only. If it is receiver is more than one variable, it will try to unpack. It will try to unpack into individual data items. So that's what happening here. Similarly, here also, if I set T1 equals to 100, 200, this is tuple. Now, if I take two variables, it will be m comma n equals to T1. Then it will be individual variables. So I'll say print m print n. So I'll execute this. So it is individual variable. Suppose if I take this, 300. Now I'll execute this. If it is more, now this is a tuple always. It is 1 minute. I want to give more 300. I want to give. So I'll take this. So this will be anyhow tuple. Now here tuple has three elements, but there are only two elements to take. Now what is happening? It is now it is m comma n. It is giving error. So it is too many values to unpack. So here the number of recipients should be equal to the number of variables there, or it should be one. Either should be there. Suppose if I take P here, so the number of items there and So here, suppose if I take M and P, now it's okay. The number of elements to unpack is matching with the number of recipients there. So it will be okay. Now it accepts. I'm printing only 2. But either it should be, the number should match, or it should be 1. If it is 1, it will be a tuple. It will not be any error. But here, this is a tuple. It will be given as a tuple, and n is actually the old value of n it is printing. So one point to note here is, generally any function, any language allows to return only one value, but Python allows to return more than one value. But if more than one value is returned, that set of values will be returned as a tuple. That is one point to note. That set of values, whatever collection of those values, whatever we are returning, it will be returned as a tuple. So that is one important thing. So that tuple may be unpacked and assigned to the variables directly in the calling function, or the tuple may be assigned to another tuple. So here in this case, the tuple is assigned to the tuple. So that's what happening here. Now in another case, here what add mult. So here it is what is going to happen here is, it will be unpacked and stored. So sm comma I'll pd I'll write. So it is unpacked and stored. So sm is integer and pd is integer. Type you check both are integers, and values I'll print here. So it is unpacked and stored. So I'll execute this. So it is unpacked and stored. So this is same thing. If I take a tuple, whether it is coming from function or I'm assigning directly, both are same. Here I'm assigning to the variable. So I can say m and p. So I'm assigning directly to the variables. The same tuple might have come from a function. So here I'm assigning, it may come from a function, it may be unpacked and stored. So when I assign a tuple to multiple variables, it is unpacked automatically. Otherwise, another reference will be added to that tuple. So this is